All right, a lot of people. That's great. Who here is a PHP developer, out of curiosity? And JavaScript? Okay. It's about half and half. It's a good thing because I was too lazy to change my presentation. It's about half in PHP and half in JavaScript. So, and my code examples will also be available, and the examples are available in both languages on my GitHub account. So I'm fairly fluent in PHP and JavaScript, and I'm much better with programming languages than actual real languages, so I can speak German. So if you want to talk to me after a presentation, please, in English, I'll be more than happy to discuss this. So machine learning. I don't know about you guys, but it seems like all we hear nowadays is always machine learning this, machine learning that. It's kind of a new trend in tech, like the new fancy trend that everybody should do and everybody should understand. And I was looking into this, and the first time I actually had to use it was about a year and a half ago. And it's actually getting easier now, but there's still a lot of things, like if you Google machine learning, you'll stumble on a lot of academic papers, and like the barrier to entry seems really hard. Like there's like this steep step that you need to do in order to understand what's going on. But I was still curious, and we actually never did any machine learning in that project because it was too much research in order to actually build what we wanted to do. But I was still kind of curious about it, and I did a little bit of research on my own, and I found out that, you know what, it's not that complex. Like we can go through some very, very basic examples, and we can do some stuff without having a hard or a very strong knowledge in maths or a big background in big data or stuff like that. So there are ways to get into machine learning that are not that hard, and they're actually quite fun to work with. So machine learning is pretty much everywhere nowadays. So it's in your thermostats and in your phone and in some chatbots, some of them that magically became some like racist robots and things like that, and that's all thanks to machine learning. So we'll see how we can work with that and how we can implement that. You might also have noticed that some of your applications nowadays are not asking you for preferences anymore. Like they'll actually learn some stuff out of you. So Google will, just in case you didn't know, will gather some information about your daily routine, and it will kind of start doing things. So there's always this dilemma between, do I want to keep my privacy or do I want to share that information? Because sometimes it can actually be useful. So my phone actually tells me at what time I should leave to work, even so that I can avoid traffic, even though I never actually told my phone neither where I work or at what time I work. But it's actually smart enough to actually do it. So that's all thanks to machine learning once again. All right, so in the next hour, we'll go through a few examples, just a little bit of an intro to machine learning. If you already did a lot of deep learning and neural networks, you can leave now because you're not going to learn anything. But if you're kind of curious, you're at the right place. So a little bit about me. Like I said, I'm not an expert in machine learning. I was kind of curious. I digged into it, and I felt that it really wasn't as complex as I originally thought. So I figured it would be something worth sharing. And it's one of the things that I really like to do in life. I like to learn about new stuff. I'm really curious, and I like to share about it. So that's why I'm doing this right now here. This is actually where I work. So it's called Spiria. We're a custom software development shop. We're based in Montreal, Canada, and this is our Ottawa office. It's actually a very cool office. It's in an old church that was converted into an office space. It has a big wow factor. And we show this to potential junior developers that we want to hire, and they're like super impressed about the building and everything because it's super old. It was built in the 19th century, like before the Canada was even born. Then I took a walk across Munich, and I figured that, boy, it's not that impressive. But it's still kind of a cool office space. So anyways, if you're ever in Ottawa or Montreal or Toronto, just let me know. I'll be more than happy to give you a visit of our small office. All right. So what are we covering today? We'll talk a little bit about theory, just to make some distinctions. We'll talk a little bit about artificial intelligence, machine learning, what they are. I'll cover very quickly deep learning and neural networks, just to kind of give you an idea of what it is. And we'll talk about different algorithms. So there's two big categories, so we'll cover those, and I'll give you two small examples of how you can implement them. Artificial intelligence. So if you Google artificial intelligence, you'll often find a lot of images like this. So often a woman, which is probably the intelligence part, and some circuit boards and stuff and robots, and so probably the artificial part, and some code. Anything weird with this code? Is Twitter Bootstrap minified? I don't know why that is artificial intelligence, but anyways. Seriously though, what is artificial intelligence? So, by definition, artificial intelligence is intelligence exhibited by machines. In computer science, the field of AI research defines itself as the study of intelligent agents. So any device that perceives its environment and takes actions to maximize its chance of success at some goal, right? I like to take a little bit of emphasis on that last part. So taking action to maximize your chance at some goal, right? So artificial intelligence basically is just a series of rules that are applied to a system. And it will kind of give the user the impression that the system is smart. So is there some examples of that? Well, of course, Pac-Man is actually an interesting example. Pac-Man was one of the first video games to introduce artificial intelligence. So there's a few rules. So basically, the ghosts, they all have their own different rules. And they follow that rule. And they're very, very simple stuff. So it's just a basic series of if you'd like. But interestingly enough, all four ghosts together kind of give you the impression that the ghosts are actually chasing you. But it's not even the case. So if you take the original Pac-Man, Blinky, the red one, I believe, just kind of tries to find the smallest path to Pac-Man and tries to follow that path. Like it's just stupid, just tries to find Pac-Man. And Pinky kind of tries to predict movement based on the direction you're facing. It will, so Pinky is the pink one, and it will kind of try to go the way that you're facing. Inky's position is based on Blinky's position, so it's a little bit more complex. It's the only one that is fairly complex. And Clyde, the last one, the orange one, interestingly enough, doesn't actually chase Pac-Man. So it kind of tries to find it, and when it gets close enough, I don't know if we see it, but if it gets close enough, it actually goes the other way. And that's the actual rule. That's how it was programmed. But this gives you the impression that, oh my God, he's trying to, to fool me, and he's trying to sneak around. But it's not actually the case. It's just trying to get away from you. So this being said, now that I've bragged about my video game knowledge, Pac-Man is actually still an interesting artificial intelligence example. So like I said, it's just a series of rules that are there to maximize the chances of the ghost to actually catch Pac-Man. Other examples of artificial intelligence, spam filters, so anything that has a series of rules to determine if something is a spam or not, or whatever it is. Fraud detection in credit card as well. So a lot of credit card, if you travel abroad, you'll notice that when you do transactions with your credit card, when they detect a credit card transaction in a foreign country, they actually cancel your credit card. It's artificial intelligence, not at its best when you travel a lot, but it's there. Machine learning. Machine learning, on the other hand, is the subfield of computer science that gives computers the ability to learn without being programmed, right? So instead of specifying a set of rules and a set of ifs to tell your application what to do, depending on the circumstances, you actually just tell it how to learn and how to make its own decisions. All right? So that's the thing about machine learning. That's what it is in a nutshell. So there's a lot of examples as well of that. You'll see your home thermostats, though that's a Nest. That's what I have at my place. So when winter comes, the screen lights up and tells me, time to train your Nest. And then for the next following few days, I'll just tell it, okay, well, when I come back to work, I'll set it to whatever, 18, 19 degrees. And then when I'll leave for the office, I'll put it a little bit lower because I don't need any heating. And I'll do that for a week or so, or 2 weeks. And it'll just be smart enough after that. And it will detect based if I'm at my home or not, and what temperature I usually like it, what temperature I like it at night, and so on. So it kind of learns everything. So I just train it for a little while, and then it learns by itself. And it's nice because it actually does the same thing during the summer. So during summer, I want to set my AC a little bit, probably a little bit higher. So I usually put it at 23 or something, just so that it doesn't go higher than that. So I'll train it again, and it will learn how to establish the rules by itself. OK Google, like I said, will learn a lot of things about you, about where you work, about where you go, what time you leave, and so on. Of course, there's also chatbots. A lot of chatbots are powered by artificial intelligence and not machine learning. But Microsoft actually did a very interesting experience last year. And they introduced Tay. And Tay was a Twitter bot that would actually have conversation with the users on Twitter, and it would respond to public tweets as well as direct messages. And when it was introduced by Microsoft, it was very nice, very friendly. It had the language of somebody in the 20s, like kind of a cool language, you know. Hey, I'm super stoked to meet everyone. And that was all nice, and she started interacting with some people. And quickly, we kind of started to see something weird going on. And as it went on and on and on, it just went worse and worse and worse until they actually closed it down. And it took 24 hours. My mother was like in panic mode. She was like, oh my God, like Twitter robots are gonna invade the world. And then I had to try to explain machine learning to my mom. But it was actually interesting. So I had to look into it a little bit to understand what happened. And it's actually very interesting. So Tay really is a great example of machine learning. And basically, she just learned based on the interactions that she had. So really, she started with a blank slate, and she just started learning a bunch of stuff. And you know, it's not really robots that you need to be afraid of. It's like stupid trolls on the internet. But yeah, so that teaches a few things. So first of all, if you provide bad data to your machine learning algorithm, they will provide you a bad input. And also, you probably want to integrate some sort of mechanism against the trolls if you have something that is public out there. All right, moving on with the theory. So deep learning and big data. So like I said, just in a nutshell, basically, you all know that there's a lot and tons and tons and tons of information nowadays that is available. And it's basically impossible to process all that data with traditional methods. So we kind of need new ways to process all of that and to interact with that data. So that's where deep learning and big data comes in. So they use stuff like neural networks in order to process that data. So very simplified, it's just a way to break down a large problem into smaller pieces so you can process more data more faster with less CPU usage. So for example, if you want to do some face recognition on a bunch of images, you would simply take a look at different shadow patterns, and if they meet the requirements that you're looking for, you trigger the next level of neurons and detecting if you have like some face patterns like eyes or noses or mouth. And then you trigger the next level to detect if you have multiple of those features, like multiple eyes, well, two, one nose, one mouth type of thing, and then you know that you have a face. I'm sorry, I'm going super fast. I'll slow down a little bit. So, two types of algorithms we're going to look at. So basically, there's two big categories. So you've got supervised learning. Supervised learning is an algorithm that you need to teach, right? So you need to provide some information to your algorithm so that it can actually kind of learn the rules by itself. and then it will provide you something. So Tay, the chatbot, the Twitter bot, was actually an example of that. So she learned based on the data that was provided by other users, and she would give out some answers based on that. Like we said, it's absolutely useless if you have bad quality of data. And it'll typically be used in classifiers. So whenever you want to, if you want to take something, some input, and put it into different categories, if you want to classify that data. So we'll see an example of a classifier in a few minutes. So we'll see how to teach our application to detect if a code is in French or in English. I could have taken English and German, but I speak both English and French, so it was easier for me. I could actually validate. So that's the type of usage that you will have for supervised learning. On the other side, you've got unsupervised learning. Unsupervised learning doesn't require any feedback, and you'll use that when you don't really expect any right or wrong answer. All right, so it will be used when you try to identify patterns or like data structures or things like that. Once again, we'll see examples in a few minutes. But it's often used for suggestions that any e-commerce site will do to you, like, oh, you might also like this. So it's based on, your previous purchases and other people, and it aggregates a bunch of data and spits out something. And the actual answer is not really important. It's not important if it's a right or a wrong answer, if you're interested or not, but it's just suggestions based on data patterns. All right, moving on to our first algorithm. So the Knavebased classifier. So that's probably the most basic type of algorithm that you'll find in machine learning. So it's simply a classifier. It's based on the Bayes theorem, which is a probability calculation. So basically, you just take the probability of A over B times the probability of A over the probability of B. Which can actually be simplified by using the probability of BA times the probability of A over the probability of BA times probability of A, plus 1 minus the probability of BA times 1 minus the probability of A, which can be generalized by using the products. So you can have multiple probabilities. So the product of A over B over the probability, the product of the probabilities of A over something like that. Let's just look at an example instead. You all know Forrest Gump. Life is like a box of chocolate. You never know what you're going to get. So let's see if it's true. So say you're allergic to nuts, and you have a box of chocolate. And you want to know if the chocolate that you're going to eat actually has nuts in it. And based on previous experience, that round chocolate have a lesser probability of having a nut than square chocolate. And that dark chocolate have a much lower probability of having nuts than light chocolates. That's all good. So let's put that into actual numbers. All right, so 25% is 0.25. And then we just take the product of those numbers. So I think I have there you go. So with nuts, with no nuts, we just multiply all the numbers. And we apply the Bayes theorem, which is actually much simpler than I explained. And you simply do the math, and the probability of having a nut in a round light chocolate is 75%. So if you're allergic to nuts, don't take a round light chocolate. Actually, if you're allergic to nuts, don't rely on statistics. It's probably not a good idea. But still, you get the concept. So basically, it's a very simple math formula. And we just check the probability of each one of those. And we just average it out and see in which category it falls. And that's all there is to it. So what does a classifier look like in code? So you have your classifier. So you just require it. And your classifier will have a dictionary. So in the example that I'll show, we'll detect or we will teach our application whether some text is in French or in English. So we'll have a dictionary of all the sentences that we've passed it. And for each word in those sentences, we will calculate a probability, or we'll count the number of occurrence, whether it's in French or in English, and then we'll just get an output or an average out of it to see in which category it falls. Does that make sense? Right, so you have typically two methods. One method to train your algorithm. So in this case, it's classify. So I give it a string, and I give it in which group it belongs. And you have a categorize. So categorize, I'll pass it a string, and it will output me the chances of being in one group or the other. Let's look at a quick demo. Does everybody know Tinder? Nobody never knows Tinder. Oh, there's one there. I know Tinder, I know Tinder. Okay. So it's the same type of interface. Basically, we'll just slide our cards, right for French and left for English. And then, this is not going to work. All right, this is going to work. All right. So I'll just start swiping a little bit. And I started, oh, there we go. So I started with a very basic, it had nothing, it had no knowledge whatsoever of French or English, but already you can see that it spotted that this card is in French. And this one is in English. Wow, it's much quicker than it usually is. All right, so it doesn't know for this one. But as you can see, it gets smarter and smarter, and eventually it pretty much detects the language for each one of those cards. And there you go, you have it. So you have your first classifier, super easy to use, very, very easy to implement. So let's look at the code quickly. Here it is. Where is it? Classifier. So the code is a little bit messy. Sorry about that. But, you know, follow the comments. So we've got a helper function just to create averages. We define our new classifier. We pass it a property, so we tell that it will have a dictionaries property. And when we do a classify, we take the string, this part here. We take the string, we split it into words. And then for each one of those words, we will do a little bit of cleanup. So we'll ignore small words like 2 letters or less, and so on. And then we'll just add, and we'll just count the number of times that each one of those words appear, and whether it's in French or in English. So we'll tell it, okay, well, we've got this sentence for each one of those words. They appeared once in whatever group was passed here. Right? So whether it's in French or in English, we'll just add those to the dictionary. And then when we ask it to categorize, that's where the code gets a little bit ugly. So basically, it just do the exact math that I've shown you earlier with the chocolate example. So it just calculates the probability of each. So it counts the number of occurrences of a word in English and in French. And then for each one, it will create those columns, multiply all of those, apply the formula, and it will simply output the highest group, so the group with the highest probability. Okay, so I get the code is a little bit messy, but still it's all available on GitHub, so if you want to take a look. And really, that's all there is to it. So 78 lines of code, and you can actually teach your application to detect some things by itself based on rules that you would provide it. So classifiers exactly like this one are used for a lot of different things. I've seen examples where they actually detect if the author of a text is male or female based on data that they've passed it. Because male authors will have a higher probability of using specific words than female. So you can do very interesting stuff with that. I have a question in the back somewhere. If I can, what, sorry?
Make the code bigger.
Bigger. I can. Should Should I go through the code again? Is it better? All right. Like I said, the code is a little bit messy, so I don't want to go line by line. As you can see, there's a lot of moving around and calculating and doing averages based on the dictionary, the data in the dictionary. So it's not super obvious at first, but I've tried to add a lot of comments there. So if you really want to look into it, it's fairly easy to follow. There's a lot of useless loops as well, just because I made it so that it was a little bit more readable, as much as I could, over performance, but you could do it much. You could optimize that code a lot. But still, you get what you kind of get an idea of how you can implement your first algorithm and your first machine learning algorithms. All right. Sentiment analysis. I wanted to talk a little bit about it because it's often confused, or people often take this for machine learning, but it's really artificial intelligence. But it uses exactly the same processes. So it uses a classifier, but it uses a predetermined list of words to detect if any sentence or string is actually positive or negative. So it can be used if you wanted to get an idea of say you're a public relation firm and you want to know what's the trends on Twitter if people want to vote for a specific candidate or another one. You can track those and kind of get an idea whether the general opinion is positive or negative. All right, so it uses a list of words that is predetermined. So instead of actually teaching the different words and building the dictionary, it's already there for you. And it also uses emojis. So there are libraries that are available, so you can use those, or you could just take the list of words and add that to your classifier. So it's interesting stuff. I just wanted to talk a little bit about it. If we take, yeah, I have plenty of time. If we take a quick look at what it looks like, come on. All right. So I built a little script here where I'm just tracking different words on Twitter. So I'm tracking 2 words, Canada and Germany. And I'll just I have 2 streams. And basically each time that there's a tweet coming in, I just check the score of this tweet. And sentiment analysis, they always use the same standards, so they return a score from -5 to +5 based on whether the sentence is actually, or the string is actually positive or negative, and how positive and negative it is. So if we want to know what the world thinks of Germany and Canada, we can actually compare both. So right now it's actually looking on Twitter, and you can kind of it's doing the average of all the last tweets in the last minute or so. So we can see that Canada is more positive than Germany. Sorry, guys. All right, so you can kind of get those scores, and then you can average them out, and you can kind of get an idea of what people feel about something in specific. This is very not scientific and doesn't give you any insight, but it can be interesting tools as well. All right. The second algorithm that I wanted to talk about is genetic algorithm. Genetic algorithm are really cool. Like really awesome shit. Awesome scheisse. So I got one word. Really fun. Lots of fun to play with. If you have the chance, write your own algorithm. It's super fun. Remember the first time that you actually wrote your first Hello World? We were out of school and you were super proud. You had like those 15 lines of code and you ran it back to your home and you showed that to your mom and you said, look, I hit run and it compiles and then poof, Hello World appears on the screen. You're super excited and everybody's like, yeah, so what? I just type it in. No, you don't get it. Like I do like this program and I tell the computer and it's like, rah, and nobody gets it. Genetic algorithm is the same thing. So until you actually write your first one, you won't get my excitement. But just fake it when I'll do a demo, right? Okay, so how does it work? So it's based on the theory of evolution by Charles Darwin, which hopefully you all know. So basically, you start with just a random population. So you take just some random individuals, and that's the actual terminology that we're going to use. So population is a group of individuals, so you just randomly create individuals. Doesn't matter what they are. And then you'll create a fitness function, and your fitness function will try to identify or give a score to each one of those individuals in your population. And then you'll just keep the best individuals. And then you also keep just a few random in there. You just put them in there. And then you'll kind of introduce random mutation in that new population. And then you'll want to get that the same amount of individuals at the end of each evolution. So you'll randomly create some children based on the parents that are there, or the pool of parents that is there. And magically, you end up with a valid solution. Right, so let's just go through that again. So you start by a random population, and you keep the best individuals, and you introduce random mutation, you keep some random individuals, and you randomly create children, and magically, you have a solution. Right? It's really cool, isn't it? So what does it do? There's a bunch of different things that you can do. Those projects are generated by Autodesk Dreamcatcher. Part of my team has the chance to work with Autodesk, great company. And Dreamcatcher, what it does is generative design. So basically, it just randomly creates different objects, different shapes, different forms. And then you specify your fitness function, and you'll tell, well, I want to draw a bike or model a bike, and I want it to be as light as possible or as solid as possible, depending on what your needs are. So if you want to do a company that does bike rental like O-Bike, you'll probably want something very solid, which apparently is not the case. I don't know if you guys have used O-Bike recently. So they're not very solid. But maybe that's what you want. Or maybe you want something to be very, very light, so you don't really care how solid it is. So you'll just include that in your fitness function, and your algorithm will continually generate new design, and more and more and more, until it finds a solution that is good enough. You can do the same thing with a skeleton for a drone and different things. Demo time. Be prepared to have your mind blown. So what I tried to do here, where is it? All right. All right. So what I tried to do here is that I simply told my algorithm, find me 4 numbers for which the sum is 200. Don't try to think of a use case for that. There's none. But I'm trying to find one individual. So each one of my individuals are arrays of 4 numbers. And I'm just trying to randomly find one for which the 4 numbers sum up to 200. All right? So I run my algorithm, and there it is. Wow. Thank you. That was actually really quick. So as you can see, in 256 generations, it found 4 numbers, so 81 point something, 17, 7, and 178, for which the sum should be very close to 200. If we run it again, 96 generation, and it's always random. It gives me 4 different numbers each time, and I don't care about the solution in this case. The only thing that I'm looking for is 4 numbers for which the sum is 200. So that's my fitness function. So this is where genetic algorithms are interesting, because they think of a problem in a way that humans wouldn't think of it. So there are examples like we've seen with the bicycles. It will come up with different shapes that we probably wouldn't have thought about, but based on our fitness function, our algorithm figures that this is the best solution for your problem, or one of the best solutions. Sorry, I got overexcited there. All right, looking at some code. Basically, we have a bunch of helper function just to help us because we deal with a lot of random stuff. Functions to generate random numbers, random integers, or so on. Let me just make this a little bit more readable. Sorry, I should have done that before. All right. And we have our fitness function. So like I said, the fitness function is what will decide if it's a good solution or not. So in my case, I'm looking for 4 numbers for which the sum is 200. So basically, I just take all the individuals, and I do the sum of the absolute value of the difference between 200 and so. So it gives me a score. And if I'm at 0 or very, very close to 0, it tells me that it's very close to 200. And then I have a function just to sort everything by this fitness so that I can keep the best individuals. Have functions to create random individuals, random population. We've got mutate function that will go through our population and just randomly introduce some random mutations. So in my case, the mutation is simply changing one of the numbers in the array for a random number. So why would you want to do that? Well, sometimes your algorithm will kind of go into a direction, and it's not exactly the good direction. So it will kind of head somewhere, but you need to introduce random mutation just to throw it off a little bit. And sometimes you'll end up with a better solution using that. And I'll show you a demo that is actually a little bit more valuable than the one I showed you. We've got a reproduce function. So you take two parent elements, 2 random elements, and you create a children with it. So in my case, I just take the first 2 numbers and the last 2 numbers of the other one, and I create a new children. So you just take random elements from both of the parents, and you create a new children with that. And you've got your evolve function. So the evolve function basically just takes care of all of those, puts all of that together, and creates a new generation. So you start with a random population, and then like I said, you'll keep the best elements based on the fitness. And you'll keep a few random individuals as well. You will run a mutation on the parents. Then you'll create new children just so that you get back to the original number. So in my case, I have a population of 200. So I want to get back to 200. And that's one generation. And then if the best individual is too far from the actual solution that I'm looking for, it will simply do another evolution and another one and another one until it actually finds a solution. So in this case, 451 generation, it actually found was a valid solution. Like I said, there's a lot of academic stuff, but it's much more interesting than the examples that I did. So what this group of academic people did is that they generated a 3D model, and they would give muscles, and based on the muscles' position and so on, some joints would be able to flex into specific, well, like this. And the goal was to see if they could teach a 3D model to walk without actually teaching it how to walk, just by specifying the joints, the muscles. And the fitness function in this case is how far can it actually walk. So it will create a population of those individuals, and it will run the evolution function on it. So it will just create a new evolution, and it will create a new generation and so on until it walks and it gets better and better and better. So you can actually see an example here. So it takes a few generations before they actually learn to walk. I like this one. Oh, good. And they did a lot of things. It's a very interesting video. The link is on my slides, which I'll share on Twitter afterwards. But they did stuff like changing the speed. So after they actually taught their model how to walk, they've changed different parameters. Like, okay, well, let's increase the speed and see how you will react to it. And because they were actually able to learn, they'd be able to react in different ways in different situations. So if you increase the speed, it will actually still work. And sometimes the best solution is not necessarily the one that you'd expect, right? So this is not exactly how you would expect something to walk, but we determined that this was the best way to do it, or not we, but. And of course, whenever you create a 3D model or a robot, you'll try to throw things at it. But this is very interesting because it actually shows that once it actually learned how to walk, it was stable enough so that it could walk even if they started throwing things, virtual things at it. And same thing with different slopes. Okay, so you can take a look at the video, very interesting stuff. I just moved to my favorite part, then, which is, of course, bloopers. So this is actually a very interesting one. And the reason why this one is interesting is exactly why I said we have to introduce random mutations. So as you can see, like the model that was working kind of like this, it will evolve in that direction as long as it doesn't have something randomly introduced that it will throw it back in another direction. So all the parents will kind of try to walk like that, so it'll create children that will kind of try to walk like that until there's something random enough that was introduced in there that will throw it back into the path of walking on our 2 feet like we all do. So I've already went quickly through that code. So basically this is how a genetic algorithm works. So it's always the same functions basically. So you'll have your evolve function. So you'll simply run that evolve function until you get an element that actually matches the solution. And you'll have the fitness function, very important. So this one is what will decide if the solution is actually a valid one. And you've got your mutation, your reproduction, and your evolution functions. All right. So what did we learn? We learned about machine learning and artificial intelligence. And if you're like me now, it's always going to bug you when you hear something on television or at the radio when they talk about machine learning, when they should be talking about artificial intelligence. We've all learned that I don't know anything about deep learning and big data, so that's why I went so fast over it. And supervised versus unsupervised. And hopefully, you won't be intimidated anymore by machine learning, and you'll actually be able to start introducing slowly some things in your own code. That's all for me. Thank you. We have a bit of time for questions. If there's any, we'll take 2 or 3 questions, and then I'll stick around if anyone wants to ask me more questions. Yes? So practical applications, finding 4 numbers for which the sum is 200. Traveling the world to show that to everyone. But seriously, the one application that we were looking at, and we're probably going to implement this as a new feature in an application that we've built, but we were working on a data transformation engine. So basically, we would get data in one format, and there were like multiple sources, and then they had to manually say to what field it actually maps on a standard output. And the data transformation process has to be manual, so first underscore name, you have to take the drop down and say, okay, this matches to first name written in camel case, and so on. And what we wanted to do is to create some sort of machine learning just so that it kind of starts to learn about, well, okay, well, this one looks very similar to this one, so let's just match them automatically instead of manually going through all that process. And there were like hundreds and hundreds of fields. So it was a very long and tedious manual process. And this one made a lot of sense for a machine learning algorithm. So we would just flag them as being, this is a suggestion, so the user would still have to go through it, but that would be a practical use case. Yes?
scientific application of PHP, and the takeaway was there are no real good solutions, there are no good libraries, and if there are libraries, they are outdated. So do you have any experience with PHP machine learning?
I don't have any experience. Sorry, so the question was that basically a talk yesterday, somebody said that PHP is not good for doing scientific calculations and so on. That's right. So I've never did any in PHP. So like I said, we've done a little bit, or we are working into implemented one with JavaScript. Definitely, they're both not the best languages for heavy or big data processing. It's probably not what you'd like to use. And even at least JavaScript keeps the dictionary for the classifiers. We can keep it in memory, but with PHP, because you do requests, if you're using it on the server, then you kind of have to store everything on a file every time and then read that or in a database and so on. So it's definitely not the most efficient way to do it. There are, though, open source libraries that are available, like TensorFlow in Python, which is very, very popular to do neural networks and big data processing. And there's also a bunch of different cloud options available to you as well. So there's IBM Watson, Google Cloud, something machine learning. Just Google Cloud machine learning. I don't know. But there is one that is available. So there are a lot of options that are available to you that are much, much more performant. So to answer your question, no, I can't think of any good library, but those are mostly examples so that you can kind of understand what's going on and how to implement them eventually in other languages. Sorry? Okay, so you could use it in JavaScript then. Yeah, so it's definitely possible. It's probably just not the most efficient way to do it, but still, like they always follow the same patterns and so on. So, thank you very much, everyone, and I'll stick around if you have any more questions. Thank you.